Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to look at the coefficient of determination. So I've got a grid laid out here, and I'm going to give us a data set. And here's the data set. The data set is the point 0, 0, so I'll put a dot there. It's the point 1, 6. Whoa, 1, 6. So let's see, here's 1, 2, 3, 4, 5, 6. Oh, let's go to 7. What the heck, for good measure. So the point 1, 6 is going to be right there. And then the next point is going to be 2, 6. So here's 1, here's 2. So the next point will be 2, 6. So I'm going to go from 2, I go up to where I come, and I come over from 6. Where those meet, I'm going to put my next dot. That is my data set. So my data set is the points, or are the points 0, 0, 1, 6, and 2, 6. Now, I would encourage you to find the equation of the line, and I've already done that, and this is what it is. It's y prime equals 3x plus 1. Now, what I would like to do first is, let's calculate, if we have our ordered pairs, so here we have our ordered pair, and I'm going to write those 0, 0, 1, 6, and 2, 6. And then what I'd like to do is calculate y prime, and then we're going to calculate the predicted ordered pair. I'll write that over there in a minute, so just so that my table looks nice here. So when x is 0, then I would put my y prime. Well, this would be 3 times 0 plus 1. Well, that's just 1. And so my new ordered pair would be x comma y prime. And this would be, xy prime would be, in the first case, would be 0 comma 1. I'll do this in another color. I should probably do these in a different color. Excuse me. X comma y prime. Okay, so that's my predicted ordered pair. So this is 0 comma 1. And my next one says y prime is going to be 3 times 1 plus 1 more. Now that's 4. So my predicted ordered pair would be 1 comma 4. Now, my last one is going to be y prime equals 3 times 2 plus 1 more. Well, that's 6 plus 1, that's 7. So my predicted ordered pair is 2 comma 7. And these are my predicted values from my linear model. So what we're going to do today is we're going to find the variation from the data set, and then the actual variation from the predicted data set. So here's what we're going to do. Let's graph this. Our points are 0, 1. I should have done an entirely different color. I'll do that. So 0, 1 is right there. 1, 4 is going to be right here, and 2, 7 would be right there. And notice this, those will nicely fit the equation of a line. Will fit right through those. There. There's the equation of the line. So let's take a look. If we want to find the variation of y and y prime. So you might say, well, what's variation? Variation is the exact same thing as variance without the denominator. So I'll write that. So we're going to write the variation of y is going to be capital V sub y, and that's going to be, we take the sum of the data values y minus their average, and then we square it. And the variation of y primes is vy prime. So that's going to be the sum of the y primes minus the mean, oops, I forgot my mean sign on the first one, squared. Okay, so what's the first thing we need? First thing we need, obviously, is we need the mean. So let's calculate y bar. Y bar is going to be, our first y is 0, our next plus 6 plus 6. Divide that by the number of data, 3, that's 12, divided by 3, 4, a 4. Now, an interesting side note is notice that the average of the y primes is going to be 1 plus 4 plus 7 divided by 3. This is also 12 divided by 3 for 4. In other words, even if you accidentally used y primes, you would still get the same mean. Now, here we go. So now that the variation of the y's, well, what do? We take the original y value, which was 0, the first y value, minus the mean of 4, and we square it. Plus, then we take our next y value, which is 6, minus the mean of 4, and we square it. Plus, we take the next y value, which is 6, minus the mean, we square it. Now, if I take all these and I add them up, well, negative 4 squared is 16. 6 minus 4, that's 2. We square it for 4. And again, for the next one, I add those up for 24. Okay, now let's do this. Now let's find the variation of the y primes. Okay, well, the variation of the y primes, well, our first y prime is a 1 minus a 4, and we square it. Plus, the next one is a 4, subtract the 4, and square it. Plus, 7 minus the 4, and square it. Well, this is going to be 1 minus 4 is negative 3. We square it for 9. 4 minus 4 is 0. We square it for 0. 7 minus 4 is 3, and we square it for 9. So this is 18. Now, before I go on a little further, let's just see what this is. So notice that we found the y bar is 4. So that's actually just a horizontal line right here at 4. This is y bar equals 4. That's the average. So then what is the variation of the y? Well, there's two parts here. And we'll color these maybe in this purple. Okay, so the distance then, the distance between the mean, which is 4, and the actual data value. So it's this distance from here all the way down to the original data value. This is the actual, or so we also used in the notes, the total. This is the total, so this is T1, this is the total variation. So T1, and then the next data point was 6, but the average was 4. So this would be the total variation calculation for the next one. This was T2. And then the last one here is, this third one is also 6. So its total variation is right here. This is the T3. So that kind of says that you could write these. You could write this as the TI squared. It's that little distance squared. Now, the next one that we've got here, we'll do in maybe this reddish orange. And now that is the distance here, the distance from the mean to what was predicted here. This we called the D. So this is the distance from the mean to what was predicted is D1. So here's another one. Well, notice in the second point, the distance was exactly the same. So this is D2, but that's just 0. And that also matches with what we found down here. And finally, our third one was the distance from the mean to the predicted value, which is this value right here. This is D3. which is, you can see, it's a distance of 3 units from 4 all the way up to 7. Okay, so there's the one last piece that's not so obvious, and that is that notice that there's these little gaps right here. This is the error. This is the third error. It's the amount that the model doesn't account for or can't explain. It's the unexplained part of the model. The model's not perfect. Here's another error. Here's another E1. And notice that E2, it worked perfect, so E2 is 0. E2 is 0. So here's what we say. Well, how good is our model? How good is our model? Well, we look at the ratio of the distances. So it's our model then. How good is our model? How good is our model? Well, what we do is we say, okay, well, notice that we have the variation of the y primes, and let's just think of what part of the whole, the variation of the y's, is this? Well, this is 18 over 24, and this just reduces down to 3/4, which is 0.75. And so we say that 75% or 0.5 of the variation is explained by this linear model. Okay, now there's one more thing that we need to see. So the coefficient of determination is this ratio of the explained variation divided by the total variation. So let's go grab an entirely new screen. We're going to go to entirely new screen. Remember, our data set was 0, 0. It's 1, 6. And it is 2, 6. So let's take a moment and calculate R. So we're going to do that. Calculate R. All right, well, here's our ordered pairs. We have our ordered pair, and we have an X and a Y, an XY, X squared, and a Y squared. So my ordered pair is 0, 0. 1, 6, 2, 6. So I have 0, 0. If I multiply those, I get 0. If I square the x, I get 0. And if I square the y, I get 0. That's not so bad. My next ordered pair is 1, 6. So 1 times 6 is 6. 1 squared is 1. And 6 squared is 36. Finally, my last ordered pair is 2, 6. I multiply 2 times 6 for 12. I square the 2 for 4 and square the 6 for 36. But that table, remember, it's just the sum of the columns that we're really after. So the sum of the x's is 3. We're after the sums here. So the sum of the x's is 3. The sum of the y's is 12. The sum of the xy column is 18. That's 6 plus 12. The sum of the x squared is 0 plus 1 plus 4, 5. And finally, the sum of the y squareds is 0 plus 36 plus 36, 72. Now let's calculate R. So we'll remember, I'll come up here. R is, I'm going to start down here. Might need some more space. So R is n times the sum of the xy's minus the sum of the x's times the sum of the y's over, we have this big square root coming. Well, that's n times the sum of the x squareds minus the sum of the x's squared times n times the sum of the y squareds minus the sum, oops, another parenthesis in there, the sum of the y's squared. And we get a big square root over all of that. So let's calculate this. So r is equal to n, which is 3. The sum of the product of x and y is 18. The sum of the x's is 3. The sum of the y's is 12. Over, so then we have 3 times. The sum of the x squareds is 5. Minus the sum of the x's, which is 3, and we square it, times, then we have 3, which is n, times the sum of the y squared, so that's 72, minus the sum of the y's squared, well, that's 12 squared. Put all that under a square root. Now we're going to kind of work through this a little bit. So we have 54. Actually, we're going to work through it completely. 54 minus 36 over, we have the square root of, the first set of parentheses, I have 3 times 5, that's 15. Minus 3 squared, which is 9, times 3 times 72 is 216 minus 144. So r is equal to 54 minus 36, that's 18. Over, well, let's see, this is going to be 15 minus 9 is 6. And then 216 minus 144 is 72. Square root of that. Okay, now, if you're not really up on working with square roots, I'll try to explain this, and let's just see what happens. So this is 18 in the numerator over 72. Let's write this as the square root. The square root, well, 72 is 9 times 8. So I'm going to write this as 6 times 9 times 8. Well, the square root of 9 is 3. So this is the same as saying 18. I'm going to write 18 as 3 times 6. Well, this is the same as the square root of 9 is 3. So I'm going to take the square root of 9 out. And inside of it, I would still have left the 6 times 8. Well, those 3's would cancel. So I'm left with 6 in the numerator and 6 times 8 in the denominator. Well, notice that 8, I'm going to write this as 6 over square root. 8 is the same as 4 times 2, right? So now I have a 6 times 4 times 2. Well, the square root of 4 is 2. So now I have 6, which is 2 times 3, over, take out the 4, that's the square root of 4 is 2, square root, and I have a 6 times 2, that's 12. So this is those 2's are going to cancel. So r is equal to 3 over the square root of 12. Now this next step may not be so obvious, and this is not a proof, it's just to show you the relationship. But I'm going to take the value of r and I'm going to square it. Let's square it. So I'm going to take 3 over the square root of 12. I'm going to square it. Well, this just means 3 times 3 in the numerator, and it also means the square root of 12 times the square root of 12. Well, 3 times 3 is 9. Square root of 12 times the square root of 12 is 12. Notice that 9 over 12 is the same as 3/4. But hold on, that's the exact same value that we got for the coefficient. This is the coefficient of determination It's the same as the coefficient of determination that we calculated in the first portion of this video. So in other words, the summary is that the coefficient of determination, it's denoted by the value of r squared. And r squared can be calculated by finding r and then squaring it, or it can be found also by the variation of the explained variations, the explained variations divided by, or the sum of the square of the explained variations divided by the total variations. I hope that helps, and thanks for watching.